Hello, everyone. Welcome to the first webinar in our series of computing training webinars. First webinar is about the new Copernicus climate and atmospheric data stores. It will be presented by Edward Comyn-Platt and James Varndell. But before I give them the floor, I will first give you a few housekeeping remarks. So my name is Milana Vučković, and I organize this series of webinars. And so to start with, you probably have noticed that all of your microphones and cameras are off. So you can ask questions in the chat or in the Q&A, but if you really want to ask to speak, you can raise your hand and I will, in the end, turn on your camera and microphone. That's about it. So I will give the floor first to Eddie to present us the updates of the Copernicus Climate and Atmospheric Data Store.
Good afternoon, everybody. Thank you for introducing us and giving us this opportunity, Milana. I'm just going to give you an update on the data store service that we provide at ECMWF. For those that are familiar with this is the climate data store and the atmosphere data store. We've recently done a big modernization of that. So if you're familiar with those, I'll be telling you about what we've changed. And if you're not familiar with those, I'll be introducing you to them in the first place. So click on to the next slide. What are the CDS and ADS? These are single point of entry websites which give you access to a wide range of data sets produced or in collaboration with the Copernicus Climate Change Service and the Copernicus Atmosphere Monitoring Service. And as well as that, there's the Copernicus Emergency Monitoring Service as well. And the idea is that we try and make all this data that's produced as part of the these services much more easier to discover and make them much more relevant to real use case applications. We want to provide users with easy to use applications so that it's possible to explore the data without being a data expert or an expert in the field. So you have to understand the details and the niche aspects of these data sets. You can do a quick exploration of them. We want to provide users with online capabilities to process the data. This makes your job easier and it makes our job easier because we're reducing the amount of data being transferred over the network if we can allow you to do a series of calculations on our side such that you only need to download 1 gigabyte instead of 100 gigabytes. We want to make sure that the data, the results that you produce.
We still see your first slide. Sorry.
Oh, the title slide. You're not on my. Okay. You don't see the bullet point.
Sorry, I see now. Sorry.
Okay, cool. Okay, where was I? Enable reproducible research. So yeah, we want to make it easier for any results that are produced from this data to be reproducible, and we want to make it easier for you to trace the results and how they were created. So whether that's providing explanations of how the data was processed via documentation, or just making sure that all these data sets that are produced have the necessary metadata such as DOIs and that sort of things, so that you can share that with your colleagues and it's the results you're showing are fully traceable. But most importantly, in my opinion, and the thing that we spend most of our time doing is trying to make you guys spend less time handling the data. So we want to make it easier for you to find the data. We want to make it easier for you to process the data and produce a good result so that you're developing the science and the applications, and we're just making sure that everything is working well in the back end. Did that slide transition work, Milana? Give me a thumbs up or a thumbs down. Thumbs up, cool. So just to give you a bit of a history, we've been working on the CDS and the ADS for the last 6 years, and the system is a distributed system. So what that means is we call ourselves the Climate Data Store, but we make it our objective to store as little climate data as possible. We rely on our data providers hosting the data, and we provide a network of what we call adapters, but these are essentially just pieces of code which can communicate with these data providers, and we serve it to our users in a nice, consistent and digestible format. This is fantastic that we can concentrate on the fetching data and presenting it to users, and we give the trust in our data providers to make sure that their data is served in a format that they understand and agree with, and it makes the relationship of providing this data from source to user much more streamlined. To give you an idea of where we got to with the old project, by the time we turned off the old system, we were serving these numbers in this diagram on the right hand side are a little before we turned off the system. We were close to 300,000 users, and we were delivering as much as 150 terabytes a day to users. So we were doing very well, and but things were growing. Our users were growing. We had saturated at the 150 terabytes. Like, we couldn't get any higher than that, so we needed to take some steps to improve the system. So we underwent a huge modernization program. And the reasons we did this were to capitalize on the 6 years of operation. So we learned lots of lessons. We did lots of things badly first time, and we sort of improved them as we went. But having the opportunity to redesign the system from fresh meant that we could have clean solutions instead of hacked together solutions, which worked good enough. We wanted to engage with a broader user community. So essentially listen to more of our customers and see what requirements they had in terms of how they access the data and what formats they want them in, for example. We wanted to make sure that we were keeping up to date with the software we were using. So various bits of the software in the old system had reached their end of life. So technology moves at a fast rate. So we need to make sure that we're updating our systems accordingly. And some of the things that we were using were out of date. So we had to update some aspects. We wanted to, I mentioned before that we did lots of things about traceability, but it was probably something we didn't do well enough in the old system. So we wanted to embrace that a little bit more and make sure that we could not only provide traceability for the things that we were doing, but also by collaborating a little bit more with our colleagues, both in ECMWF and across the Copernicus services, meant that our components were a bit more easy to use in different services. And that leads to strengthening synergies with the other related platforms. I don't know if any of you guys use Wikio, but that is a project that we're also very closely related with. So we wanted to make sure that what we're doing was much more usable for Wikio users. Okay, so to put some substance behind all those claims I just made, regarding the deployment of the system and upgrading the software, we moved to a Kubernetes deployed system, which means that it's much more modern and it's much easier to scale this up. So we won't be we won't reach saturation quite so quickly, and it gives us, as we get more and more users, we should be able to grow our system accordingly. In terms of creating the synergy and the traceability, we've adopted the full and fair principles, which is findable, accessible, interoperable, and reusable. These are a series of recommendations that people that are serving data to a community should follow, such that humans can trace the data, but also machine learning algorithms can also make use of these catalogs and learn from not just the data, but also from the metadata that supports them. And in terms of our online processing that we offer, in the old system, we had something called the CDS toolbox, which was very powerful in some respects, but it was also quite limiting and had a huge learning curve. So James will give you a nice demo of where we're going in this direction, but we are moving towards a Jupyter hub. I think a lot more of the community are familiar with Jupyter notebooks and that technology. And the software that we're providing is EarthKit, which is ECMWF software. And what's fantastic about that is it's the pool of collaborators to EarthKit is no longer just the CDS team at ECMWF, but it's the whole of ECMWF. And we're creating a library of tools which everybody can use, contribute to, and make use of. Which brings me on nicely to my next slide, which is EarthKit. EarthKit is the namespace for ECMWF open source Python code. It's too much for me to go into in one slide of a presentation now, but I encourage you to go to the EarthKit Read the Docs page for details. The EarthKit Read the Docs is kind of the parent page, and there you'll find links to all the sub packages and how you can use them going forwards. James will demonstrate some of these packages, I think specifically EarthKit plots and EarthKit transforms. But underlying that is a package called EarthKit Data, which we hope will make your lives of handling data objects so much easier, because it can understand many different file formats and put them into the data format that you need for your Python code to run successfully. James is going to go into more detail on that, so I'll brush over that one and move on to the next slide. So to support all this new software and infrastructure, and to aid in the traceability of the things that we produce as part of the Copernicus services, we've drastically expanded the training material and documentation in Jupyter Notebook format. And what's great about that is that it gives people that produce data or produce scientific results the opportunity to provide the code to users alongside some nice human readable documentation. And what's great even further is that we can ingest these straight into our Jupyter Hub, so they're immediately accessible to anybody using our Jupyter Hub. We've got a series of notebooks. I've not included the links here, unfortunately, but we can provide those later. These vary from the documentation behind the EarthKit packages, which is the image in the top right, to the a series of notebooks which describe how to access data and use the ADS and the CDS, which is the images on the bottom left. And then this sketchbook Earth, the Illustrated Climate Chronicles. This is a traceability Jupyter book, which provides notebooks which describe how you calculate the various climate metrics which are produced as part of the C3S Climate Intelligence Report. So it's both educational and traceability documents, and achieving many of the goals that C3S set out to achieve in all the years ago when the service first started. And as I mentioned, these will all be accessible from our Jupyter Hub. Unfortunately, we did not get Jupyter Hub ready in time for the release of the new system, so we expect this to be available to the public in early 2025. We're just testing the system now, making sure it works well, and there's some less exciting things, such as making sure that the terms and conditions have fully described the service that we're offering and what people are allowed to do with it. James is going to give a demo of how to run a Jupyter Notebook. Until we're fully public, if you're looking for somewhere to execute notebooks, Wikio is a good service, and you can also execute these locally. It's just when we have ours up and running, it will be nice and close to the data so that you can do some downscaling of your data, for example, before downloading it. And as well as the improvements in the kind of online processing, we are hoping that the applications that we publish in the new CDS are much more user-friendly. In the old system, they were kind of tied to the toolbox, which was great in some ways, that it was very simple to create a simple application to deploy on our system. However, it was quite limiting, and our web developers often found they were unable to do the things that they wanted to do. We've taken a much more open approach to application development. This means we trust our application developers to develop in JavaScript or any other web front-end framework, and it means they can produce these beautiful applications such as the Climate Pulse and the Climate Atlas, which are both accessible. I hope these QR codes are still valid. I created them about 6 months ago, and they have about a 6-month lifetime. So you'll find out when you search them and try and get them. You can also access them directly from the new CDS pages on the Applications tab if you want to find them that way. Another aspect, this is aimed at people that are used to the old system. An application we had on the old system that we've not repeated in the new system is the daily statistics application. This was a very popular app. It was being used hundreds to thousands of times per day. It was part of the reason why we changed the system, is that because it was so popular, it started causing problems in the old system and clogging up our queues and reducing the data service we offered. To address that, we've now added the ERA5 daily statistics as a catalog engine, as a data set in the new system. It's a post-processed data set, so the code that's being executed on the data is the same as the old application. It's just executable via a catalog entry, and then you get handled in the queuing system like you would if it was any other data set. This hopefully makes the daily statistics data much more accessible for you. It's much more like if you're downloading hourly or monthly data, and it also makes it easier for us to manage the resources required to return this data for you. And then one final slide is we've embraced the evaluation and quality control a lot more in the new system. This means that from the dataset pages, it's possible to explore all these evaluation and quality control reports that are produced as part of C3S. And further to that, they're now producing a lot of these reports in Jupyter Notebook form. So should you want to take a look at a quality assessment that's been carried out in the past, you can take that report as a notebook and execute it yourself, maybe changing some of the variables or data sets that they're using for their assessment so that you can produce your own quality assessment along the similar lines. I'm going to pass over to James at this point. I've got a little roadmap of where we are and where we're going, but this is a slide from an older presentation, so if there's any questions now, but I'll take questions after James's live demonstration.
Great, thank you very much, Eddie. So I believe Milana will now share a link in the chat for you all to a Jupyter Notebook, which you can all follow along with for the following live demo. It's not all Python stuff, but a Jupyter Notebook seemed like a good format for the next tutorial. So I'll take over the screen share. So hopefully you can all now see my screen share. Has that all worked okay? Can I get a thumbs up? Can you see that? Ah, perfect. Okay, great. So I've got a Jupyter Notebook here, which you can all follow along with, but I'm not going to treat this like an actual training session. It's more of a demo, so I might go a bit too quickly, but all of these resources are available for you to come back to at any time. So in this notebook, we're going to explore a little bit about your first time accessing the Copernicus Data Store services, particularly the CDS, but everything we cover here is also true for the Atmosphere Data Store and the new Early Warning Data Store as well. I'll briefly touch upon how to create a new account, and then we'll explore how to access data sets through the Data Store websites. Then we will explore how to access data using the Python API. And finally, we will touch a bit on EarthKit, which Eddie covered a little bit in his presentation, and how you can use that to build a complete workflow of data access, processing, and visualization from the data stores. So to get started, we have 3 core data stores at the moment: the Climate Data Store, the Atmosphere Data Store, and the Early Warning Data Store. So we're going to start by having a look at the Climate Data Store website. So I'm sure a lot of you are already very familiar with the CDS, but if you're not, the first thing you'll want to do, if I log out first, is you will want to log in or register. If you don't have an account, if you click on this, for me, I think it will automatically log me back in because I have an active session open. It will ask you to create an ECMWF account. So one thing that's important to note is if you had a Climate Data Store or Atmosphere Data Store account in the past, those credentials will no longer work with the new data stores, and instead you need to associate your account with an ECMWF account, which you can create for free. Once you have logged in, it will take you to your profile page, and I think initially you will have to fill in your just a few details about yourself, where you're from, and the sorts of things you're interested in, and then you'll be able to start accessing data. So the core feature of the CDS is our great catalogue of climate data sets. So if you click on data sets at the top, you come to our catalogue and our search page. So I'm going to walk you through accessing some data from ERA 5 reanalysis. So you can search here ERA 5 monthly. That's what we're going to go for. You can see I've made these sorts of searches quite a few times before. So we're going to go ERA 5 monthly single levels. And the top hit here is the ERA 5 monthly average data on single levels data set. So we go ahead and click on this. And for all of our data sets, we have a nice unified interface. So behind the scenes, all of our data sets, as you saw in Eddie's slides, come from a wide range of different sources. So we are data set brokers. A lot of the data, some of the data we have ourselves. So ERA 5 is an ECMWF data set, but plenty of our data sets come from a huge range of providers who have data in different formats, coming from different sources. And the great thing about the CDS is that we have a unified interface to access all of those data sets in exactly the same way. So it doesn't matter to you as a user where the data comes from, what format it's in, anything like that. You always get the same unified interface. So every data set has an overview which explains a bit about what the data set is. and then some more sort of metadata about exactly what's in this data set. So ERA5 is a gridded data set, has a global coverage. It talks a bit about the resolution of the data and the temporal coverage. And then we also have a big list of all of the variables in the data set and a detailed description of each one. So let's go ahead and have a look at the contents of the data set. So if you click download, you will see this download form. So these download forms look essentially equivalent for all CDS data sets. So you always just have a series of widgets where you can manually select the data that you're interested in, and then you can submit your request at the bottom of the page. So in the example in the Jupyter Notebook, which I can quickly switch back to, so we're accessing data through the data store websites. We talk about a nice example to get started here could be exploring sea surface temperature between El Nino years and La Nina years. So what we're going to do, if I go back to the data store, we're going to access some monthly averaged reanalysis from ERA5. We're interested in sea surface temperature, so I'm going to select that variable. And then if I scroll down, you can see there's a lot of variables available for ERA5. We are interested in comparing El Nino and La Nina years. So we know that an El Nino year was 1997. So if I find 1997, I select that. And 1998 was a La Nina year. And I also know that 1993 was a more normal year. So we can select that as well to have something to compare the El Nino and La Nina years to. The differences in sea surface temperature during El Nino and La Nina years are much more visible in a month like December. So let's select December as the month we're interested in. Of course, you can select multiple months, and we could select a lot more years as well, but let's keep this selection small just for this example. And you do have to select a time as well. As we scroll down, we also have a geographical area selection. So because we're looking at El Nino and La Nina data, we're probably mostly interested in the tropical Pacific Ocean. So we can restrict the amount of data that we access from ERA5 by passing a sub-region extraction in here. So for example, we could go from 20 degrees north to minus 20 degrees south, and then from about 100 degrees west to 300 degrees east, which is equivalent to minus 60 degrees. As a data format, you can get the data in netcdf or GRIB. In this case, I'll go ahead and select GRIB. And then you can also select a download format. So this, I'm going to say unarchived, so we should get a single GRIB file back. But if you, for example, are making lots and lots of requests that could have an arbitrary amount of variables or data in, it might be useful to select zip so that you always get zip files back from the CDS. And you can see the equivalent API request at the bottom of the page, but we'll come back to that in a minute. For now, we're just going to click Submit Form. And that has submitted a request here. You can see it was queued. Now it's in progress. So this is our request we just made. While it's running, well, here we go, it's just completed, but you can click on the Details tab. Click on the Details tab, and that will tell you what you just requested. So you can see this is equivalent to the request we just made. So we just requested sea surface temperature for the years 1993, 97, and 98 for the month of December. And we've got our geographical area in there as well. So once you've done that, you can go ahead and click the download button, and that will simply download the resulting GRIB file to your local machine. So yeah, hopefully that's just very straightforward to access data through the web interface. Let's go back to this Jupyter Notebook. This is where I just cover exactly what I've just been through. One thing that might be quite useful to many of you is, instead of accessing the data through the web forms, accessing the data programmatically using our Python API. So we provide a Python library called the cdsapi, which is linked from this notebook. And you can download the CDS API with a typical pip install, so just pip install CDS API. In order to use the CDS API, you need to provide it with your credentials. So I'm going to show you how to do that, but you can always, if it's too fast, you can always come back here and follow the tutorial in the notebook. But from the Climate Data Store, if you go to the top right corner of the page, and this is also true in the Atmosphere Data Store and Early Warning Data Store. If you click on your profile, it will bring you to your profile page. And this will show you your user ID and your personal access token. So here, for example, I have my personal access token. So I'm going to go ahead and copy that. And then in this webinar notebook, we actually have a nice little code snippet you can run that will automatically set up your CDS API-RC file. So if you run this little cell here, what it will do is it will take your key that you just copied from your profile, and it will put it in a file called CDS API-RC, which will be in your home directory. So if you go ahead and do that, then you should have access through the CDS API. It should be able to read this file and automatically use your credentials to request data from the Climate Data Store. So now that we've done that, we can go ahead and make a request for the CDS API. Let's go back to the Climate Data Store, and I'm going to click on your request in the top right to go back to the summary of the requests I've made. So at the top here, we have that request that we just made. I'm going to click on Details, and then I'm going to click on this Open Request Form button, which will return us to the web form with all of the selections as they were before. So this is the same request we just made. So we're back to sea surface temperature for 1993, 97, and 98. But this time, instead of clicking Submit Form at the bottom, I'm going to click on the Show API Request Code button. And that will give you a nice little code snippet that you can copy and paste into your Python session. It could be a Jupyter notebook. It could just be Python interpreter on the command line. Here I have that already copied into this Jupyter notebook, the equivalent request, and then you can run this, and it will give you some nice messages, including warning messages that come from the CDS. So whenever there are any issues or any important information about data sets, we can issue these to users through the CDS API as well as on the web page. So you see I've submitted my request, it's been accepted, and it should be submitted in a moment, and then hopefully we will get the data back. But this is completely equivalent to the request that we made in the web portal. The only difference doing it in the API is that it will download the data where you run your download command. But of course, using the API, you can set up scripts to, for example, pick up new ERA 5 data as it comes in, or other data sets that are regularly updated, or write your own scripts which can iterate over years or interesting bits of data to get the data you're interested in programmatically. So for some reason, maybe it's because lots of people are accessing the CDS API at once, but it seems to have not got past the accepted point. I'll continue with the tutorial. We can come back to this in a moment. So the last thing I wanted to mention is accessing data store data with EarthKit. So in the previous sections, we explored how to get the data directly through the web and also through the Python API. And in both of these cases, we downloaded the data directly onto our machines as grid files. So in the following section, instead, I'm going to use EarthKit, which constructs a workflow of data access, processing, and visualization, all within the Jupyter Notebook or your Python session. And our API request did just complete. There we go. I think it's probably just high traffic right now. Yeah, let's continue with the EarthKit example. So EarthKit is a Python package which provides tools for accessing, processing, and visualization of Earth science data. In terms of access, EarthKit can access data from the data stores like the CDS and the ADS and the EWDS, but it can also access data from any URL that some data might live at, or a local file on your machine, or FDB if you're familiar with FDB. And there's quite a few other source types as well. So it's a very flexible way of accessing data from an arbitrary source, which of course also makes it easy to combine, for example, CDS data sets with some local data you might have. What we're going to do is we're going to use EarthKit data I should explain, EarthKit is split up into multiple components. So we have EarthKit data is a library for doing the data access. And we have other libraries like EarthKit transforms, EarthKit Meteo, and EarthKit plots, which Eddie mentioned in his presentation, which we'll get onto in a moment. But to start with, we're just going to use EarthKit data to make the same CDS API request we just made, but through the EarthKit interface instead. So the EarthKit interface is pretty much equivalent to the CDS API. The only difference being that we need to tell it that we're getting data from the CDS specifically. So EarthKit data has this function called earthkit.data.fromSource, and we need to tell it that we're getting data from the CDS. But just like we did above with our CDS API request, we are just passing the name of the data set and the payload of the request. So again, you can see we're still getting the same data, sea surface temperature for the years 1993, 1997, and 1998 for the month of December. If I go ahead and run this, hopefully the queue will have eased up a little bit. But while that's running, I can continue through the notebook. So under the hood, that is still making a CDS API request. The difference here with EarthKit data is that the object that's returned, this data object that we get back, is what's known as a field list in EarthKit data. So this is now an object that we have in our Python session that we can pass to other EarthKit components. So instead of just returning a grid file, we now have an object that we can analyze and visualize within our Python session. So one thing that you might want to do with that, for example, is convert it to Xarray or other commonly used open source scientific tools. So we have, for example, to pandas, to NumPy in there as well. So in this case, if I try and convert that data object to Xarray by running data to Xarray, you can see that we get a nice Xarray representation of our data set. So we have our sea surface temperature in there, and we have our 3 time steps. In fact, if I expand this, yeah, we have we have 1993. I should look at the data. 1993, 1997, and 1998. So if you're familiar with Xarray and Xarray related tools, you can of course convert your data to Xarray and use whichever tools you're familiar with. But the other big advantage of using EarthKit data to access the CDS is you can pass that data object on to other EarthKit tools. So in this case, there are libraries like EarthKit transforms, which Eddie mentioned, which has lots of tools for processing data, CDS data sets or any other data. And we also have EarthKit plots for visualization. Just to keep this example simple, we'll stick with just using EarthKit plots to visualize the 3 different years of sea surface temperature that we retrieved. And then we can compare how the sea surface temperatures change in the tropical Pacific Ocean. So it's relatively little code to do this. I've just labeled each year. So we know 1993 is a normal conditions year, 97 was an El Nino year, and 1998 was a La Nina year. I've also designed a style here. So a style is just the color map essentially that we're using to visualize the data. EarthKit plots also provides the ability to pass units as part of your style. So with ERA 5, for example, temperature always comes back in Kelvin. But for visualization purposes, it's often much clearer to many users to visualize that as Celsius. So if you define your style with units of Celsius, then whichever temperature data you pass to your visualization, it will always try to convert those units to Celsius. So for example, if you had data that was in Fahrenheit, that would also convert to Celsius automatically. And then we create a figure in EarthKit plots. I won't touch too much on exactly what all these things are. There are lots of tutorials in the EarthKit plots documentation, which is linked here in the notebook. But then we iterate over our years, add a map to our figure with the domain that we specified above. So this is the tropical Pacific Ocean. And then we plot each bit of our data using the style we defined above and give it a nice title. And then finally, this last section, we're just adding a few ancillary layers like land polygons, grid lines, and finally a title. So this is something that's a very nice feature of EarthKit plots. You can use templates and titles. So here we have, for example, variable name in and then time of time. So these are being formatted with the month name and with the year. So this is automatically, as you can see, if I scroll down, we can see the image that's generated. This title has automatically detected that the variable name is sea surface temperature, that the month, which comes from this time %b, this is a standard time format key in Python, that's come back as December because we have December for all of our time steps. And then I've also asked for the year, and because we have 3 years, it's automatically formatted that as 3 years. And then we have our three different years here. So we have our normal conditions, we have our El Nino here, and then we have our La Nina at the bottom, and then a nice color bar as well. And again, we were able to label that color bar using the same templating method that we used for the title. So I've said give it the variable name and the units. So it's automatically put a nice the variable name and a nice units label on that color bar. So I know that was a lot of information at once, so feel free to come and access this notebook, play with it yourself. You could try changing the units here, try if you wanted to plot it in Fahrenheit, you could do that, accessing different years, different data, and see how this templating all works. I was also just going to touch upon how you can provide feedback and get some support. So I've put a link here at the bottom to the CDS help page. So in the CDS and the other data stores, we have a virtual assistant, which you can access from the help page or at any time by clicking on the rubber duck. And then you can ask the rubber duck questions. For example, you could say things like, how do I access ERA 5? And it should give you some information about all of the different ERA 5 data sets which are available. So you can always ask the virtual assistant for some of the more straightforward help. We also have a documentation center and lots of training materials that are available. But if you have any issues that you can't resolve through these means, then you can always feel free to click on Contact Us, which will take you to our support portal where you can raise an issue. And that will go to our very responsive user support team. The last thing I wanted to touch upon briefly was the new applications that we have available in the Climate Data Store. So some of you who are familiar with the old CDS may have been familiar with some of the interactive web applications that we made available there. And they were all developed using the CDS toolbox, as Eddie mentioned, which was great in many ways because it meant you could develop a web application using just Python, but the resulting applications were not particularly performant because they required running using the same infrastructure as normal CDS requests. And also the features we could implement were quite limited because the tools had to be compatible with the toolbox, which meant it was quite hard to do proper web development just through a Python interface. So moving forward, we have been designing proper web applications using proper modern web tools. And we have a couple of applications already available. So we have the Copernicus Interactive Climate Atlas, which you can use to explore many different climate projections, reanalysis and observations data sets and have a look how they have all changed over time. We also have Climate Pulse, which is a very simple website which simply shows the current state of the global surface air temperature and the equivalent anomaly. So you can keep track of the most up-to-date ERA 5 data we have for tracking the global surface air temperature. As you can see, it's 16th of November today, so we're 2 days behind real time. And you can also visualize that in an interactive globe as well, which you can select a date that you might be interested in. So we can look back over the last few days and look at how the temperature anomaly or the absolute temperature has changed over time. So these are all developed directly on top of ERA 5 from the Climate Data Store. And we also have hot off the press, not yet on the applications page, but it will be published there in the coming days. We have a new C3S Global Temperature Trend Monitor as well, which is a simple application for exploring how close we are to reaching the 1.5 degree warming limit as agreed in the Paris Climate Agreement, and also how the rate at which we approach that threshold has changed over time. in a nice animated graph. And here we have some Python source code, which you can follow to access the data using EarthKit and then visualize the data in exactly the same way as we do in the application. So we make it as traceable as possible for users to really get into the nitty-gritty of how we process all of this data. Great. So I was worried that I've run out of time, but I've actually finished a little bit early. So I think I'm happy to go on to questions, Milana.
Yes, thank you very much for the both of you for the great presentation. So we had a few questions in the Q&A, and some of them we answered. So there is one. First, I would like to read this question. Could you give a short summary of what is the difference between ADS and CDS?
Sure thing. Shall I reshare my screen? I can show you the two different things. So the Climate Data Store is basically the data store for the Copernicus Climate Change Service. So this is where we have lots of climate-related data sets. There's a wide range of things in here. So we have climate reanalysis, observations, projections, seasonal forecasts, and a bunch of other things in there too, all related to the state of the climate, past, present, and future. And the Atmosphere Data Store is the equivalent service for the Copernicus Atmosphere Monitoring Service. So this one has got data sets which are much more, so I need to accept these terms and conditions. Data sets which are much more to do with atmosphere monitoring, so greenhouse gas forecasts, air quality forecasts, and all of those sorts of things. And then again, we also have the Early Warning Data Store as well, which is much more data sets for things like flood forecasting, forest fires, and those sorts of things.
Great, thank you very much. Next question is, can I also have the GRIB data into ZAR format?
Great question. Right now, the only data formats that you can access through most CDS data sets are GRIB and NetCDF. I don't know if there are any plans in the short term to also offer those as ZAR, but Eddie may know more.
No, I'm not sure that there is. Usually you find behind ZAR is NetCDF or GRIB anyway, right? So if you want to do that, my suggestion would be to get it as GRIB or NetCDF and then use something like Xarray to store that as ZAR. But it's not a service we're planning on offering in the near future.
Thank you. The next question is about the support. So can you request a chat with a real duck? I'm guessing this is about, can you talk to a real person through the chat?
Yes. Unfortunately, not a real duck. That would be great. No, you can request, as I showed in the help page, there is an option to raise a ticket with user support, and they're very responsive and they'll be happy to help you.
And just a small thing to add, there is also a user forum where users can ask the community, and then somebody from the community maybe also can answer or add to the discussions. Next, do you have the plans to expand or add more data sets to the EWDS?
Yes, it's an ever-growing catalog. So what was it specifically to the EWDS, or was it for all data stores? Was that Milana?
Right.
Was the question regarding all data stores, or was it for the EWDS?
No, it's specifically EWDS.
Okay. Sorry, I thought you were talking about all data stores. I can't give you an update on that. I think that the CDS and the ADS are growing, weekly or monthly. Maybe EWDS is a little bit slower at growing, but I think there are various data sets on the horizon. Fire has become quite a prominent topic at the moment, a hot topic, if you don't mind me punning a little bit on that one. And yeah, and I think there are a few more flood data sets coming. So yes, in the future, but I'm not sure at what rate they will arrive.
There are usually announcements on the forum when there are new data sets, so you can watch those on the forum and then you will get notifications. Next question is, a couple of times I wanted to download relative humidity and also UV flux. Is this anywhere included in the data sets, ERA 5, because this user couldn't find them in ERA 5?
I think the answer is relative humidity is not in ERA 5, but it can be calculated from the temperature and the dew point temperature with a quite straightforward equation. As for UV flux, Eddie, do you know? I think that might be available in ERA 5. Or we have downward UV radiation at the surface. I must admit, it's not really my, we do have, sorry, we do, yeah, mean surface downward UV radiation flux. I think we have quite a few different UV variables in there. Not sure if it's exactly the variable you're interested in, but I would go and have a little look, explore all of the variables that are available, because there may be, that may be covered.
And the last question that I have here, can EarthKit also be used to access CMIP data directly at ECMWF?
It depends. There is some data at ESGF which can be accessed if you just have access to the public URL. And if so, then you absolutely can use EarthKit data's URL source type to get that data. If it needs to go through a service that's available at ESGF, then the answer is no, not right now. You can't do that directly through EarthKit. But there are some data sets in the Climate Data Store, like CMIP6, CMIP5, and Cordex, which are they are actually all built on top of ESGF data sets. And you can very much use EarthKit to access those, but not directly right now, no.
Thank you. I don't see any more questions. So I would like to just add that these questions about, for example, calculating relative humidity, we will take these as the requirements, and then it might be added to one of the EarthKit components to have a formula to calculate the relative humidity in the future. So thank you very much, James and Eddie. I want to add that this webinar, as all the other webinars in this series, are being recorded, and the recordings as well as slides in Jupyter Notebooks will be shared after we do some editings of the recordings. Also, I want to mention that next webinars in the series is tomorrow morning at 10 a.m. UTC or 11 Central European time. It will be exactly about EarthKit, so it will follow nicely to today's webinar. And I want to thank all of you for joining, and I'm looking forward to seeing you tomorrow in the both webinars. Thank you very much.